Hello everybody, welcome to the video. Today we're going to be going over how to graph the general form of the equation of a circle, which looks like this. Notice that you have the x squared and y squared. You have terms with just x and y and a constants. And in this case, x and y are going to be just regular variables, kind of like y equals mx plus b for a line. And a, b, and c are just going to be constants. Sometimes x squared and y squared are going to have coefficients. We'll deal with that later on, but in general, this is the equation of a circle right here, and we're going to be going over how to graph it. So to begin, as you guys know, there's this form of the equation of a circle, which is called standard form. So this is what we went over in homework 8A. So our goal today is to basically go from here, the general form, to here, which is standard form, using algebra. Once we get it to standard form, then we're going to be, good to go, and we'll identify the center and the radius to graph this thing. So the layout of the video is going to be like this. I wanted to review real quickly how to graph with standard form. I wanted to review how to factor what's called perfect square trinomials. This was a concept from last semester, so I wanted to refresh your memory from that. And then we're just going to go over two examples to make sure that you guys understand how to do the homework. Okay, so real quickly here, just a review of what we learned in lesson 8A. This is the standard form of the equation of a circle, right? So for example here, this is in standard form. The center would be the opposite of -3 and the opposite of 1, which is 3, -1. The radius would be the square root of 4, which is 2. So you can use that information to graph your circle, kind of like I did here. Okay, so that's the standard form of the equation of a circle. I also wanted to review factoring trinomials with you guys. It's been a while, and you guys might need to know how to factor these in order to do the problems today. So if I was to ask you to factor this, you should remember how to do that. So this is a trinomial. It has 3 terms, 1, 2, 3, and it's a quadratic trinomial. So that means that to factor this, you have to think of 2 numbers that multiply to 16 and add to 8. So can you think of those numbers? The 2 numbers that multiply to 16 and add to 8? And are those numbers the same? They should be, right? So the 2 numbers are +4 and +4. So the way to factor this is to write this as x plus 4 times x plus 4, right? Because x times x is x squared, 4 times 4 is 16, and then you have 4x plus 4x, which is 8x. And by the way, another way to get this, another way to write this would just be x plus 4 quantity squared. Okay, so that's the algebra for factoring trinomials. If you wanted to do something like this, once again, you'd have to remember, okay, so what 2 numbers multiply to 25 and add to 10, and those 2 numbers would be 5 and 5. So you're going to write it as x plus 5 times x plus 5, which is x plus 5 squared. Okay, and here's just another quick example. The difference here for this example is that this term is negative. So the 2 numbers that multiply to 36 and add to -12 would have to both be negative, right? So this is going to be x minus 6 times x minus 6, which is x minus 6 squared. So for today, all the trinomials that you're going to see are going to be what's called perfect square trinomials. That means that the 2 factors here are the same. X plus 4, x plus 4, x plus 5, x plus 5, x minus 6, x plus minus 6. That's going to be the same. And so a nice pattern that you might recognize here to get the factored version a little more quickly is to realize that if you look at these numbers in red, all you have to do is take that middle coefficient and just divide it by 2 to get these numbers down here, right? So 8 divided by 2 is 4, 10 divided by 2 is 5, and -12 divided by 2 is -6. So that's a way to get that. And if you square those bottom right numbers, you will get these purple numbers. So it works out, okay? So remember guys, in this lesson, all the trinomials will be perfect square trinomials. So when we get to this step, just realize that you can just take the middle term and divide it by 2 to get this term right here. All right, everyone, so with that review out of the way, let's get to some examples here, starting with this one. So graphing circles, the general form, starting with this example 1. So here we have an equation. It's in the general form for a circle, and we have to graph it, which means that we have to change it to standard form. So let's go over the steps for that. Step 1 is to move the constant by itself and group the variables together. So in this case, the constant is going to be 95. So we subtract 95 from both sides, and then we write it on the other side of the equation. We get 0 minus 95 is negative 95, okay? And also notice here that I grouped the green x terms together right here, and I grouped the purple y terms together, which are right here, okay? So that's the first step, is to kind of group everything sort of like that. The constant goes by itself here, the x's go together, and the y's go together, okay? Step 2, what you want to do is you want to complete the perfect square trinomial for the x's and for the y's. So the way to do that is that you have to take the coefficient of x, which in this case is 4, divide it by 2 and square it. You might remember that that's how to complete the square to solve quadratics. And then you want to do the same thing for y, okay? So for this step right here, we're going to take a look at these terms. Notice that the coefficient here is positive 4, the coefficient here is negative 22. So we're going to take those two numbers, and then we're going to divide them by 2 and square them. So when you do that for 4, you get 4. When you do that for negative 22, so you get negative 22 divided by 2, that's negative 11 squared, and you get 121, okay? So what do we do with those numbers? Those are the numbers that we're going to use to complete the perfect square trinomial. So you put them right here, okay? That's why I kind of left the space there, because you have to add 4 in this case and 121 in this case. Now, because this is an equation, you also have to add it to this side of the equation too. So if you add 4 here, you also have to add 4 here, and if you add 121 here, you also have to add it right here as well, okay? So that's going to be the case there. Okay, everybody. So then once we do that, what we're going to do is move on to step 3. And step 3 is we're going to factor the left-hand side and add the numbers on the right-hand side. Okay, so this is why I did the review for factoring perfect square trinomials. Notice that what I have here in green is a perfect square trinomial, and what I have here in purple is a perfect square trinomial. And then we're just going to add these 3 numbers on the right-hand side. So let's do that. Okay, so what 2 numbers multiply to 4 and add to 4? That's 2 and 2. And in this case, what 2 numbers multiply to 121 and add to negative 22? That's negative 11 and negative 11. And then we just add up these numbers. If you add negative 95 plus 4 plus 121, then you get 30, okay? And of course, another way to write x plus 2 times x plus 2 would be x plus 2 squared, and then the same thing for y minus 11 squared. So guys, if you want to go straight from here to here, you can do that. And remember this sort of shortcut I told you, the pattern here is that you can take the middle term right here, which is 4, divided by 2 to get 2. And don't forget to square it. And here you take the middle term, which is negative 22, divided by 2 to get negative 11. Okay, so we've actually transformed this original equation in standard form. So now that it's in standard form, we'll be able to graph it just like this. Okay, the center is going to be at negative 211, right? That's the opposite of 2 and the opposite of negative 11. The radius is the square root of this number, which is square root of 30. Plug that into your calculator, you'll get about 5.5. And then we're going to use that information to graph this circle. So the center is going to be here at negative 211. The radius is about 5.5, square root of 30. And then you can use that to get your circle. Okay? So that's what we've done, you guys. We've transformed this from general form to standard form, identified the center and the radius, and then you got your circle, okay? So I know there's lots of algebra involved in here, but if you just follow those 3 steps, you should be able to get your solution, okay? All right, everybody, so let's go over this last example here. And notice that in this equation, we actually have a coefficient of x squared and y squared that's not 1. The coefficient here is actually 2. So what you have to realize is that should be divided out, okay? So in this case, when it's not x squared plus y squared, when you have another coefficient, you have to divide everything by the coefficient of x squared and y squared first, okay? Now, what if the coefficients are different? So if the coefficients are different, like for example, if this was 2 and this was like 3 or something like that, If that's the case, you guys, then it's actually not a circle, and I'm going to talk more about that later. But as you'll see for all the examples on the back side, these two should be the same number. So actually what we're going to do, guys, is we're going to divide all the terms by the coefficient of x squared and y squared, which is in this case 2. So that's going to be the first step here for this problem. Okay, so once you do that, so the 2's here cancel out. You have negative 14 divided by 2, which is negative 7. Here you have negative 10 divided by 2, which is negative 5. We have 35 divided by 2, which is 17.5. And then that equals 0 divided by 2, which is just 0. So that's your equation. Then we're going to follow the steps that we did in example 1. So we move the constant to the other side like this. We group the x terms and the y terms together, and notice that the constant is still here. And then we move on to step 2. Okay. Now, when we do step 2, when we take the middle term, divide it by 2 and square it, notice that the middle term is odd. So in this case, this is 7 and this is 5. So when you take an odd term and divide by 2, you get a decimal, you get a fraction. Okay. So the work I did here in red is I took the negative 7 right here, the negative 7, I divided it by 2 and I squared it. So 7 squared would be 49 and 2 squared would be 4. So this is going to be 49/4. That's the number that we have to put right here. Okay. In blue here we have negative 5 over 2 squared. So 5 squared would be 25 and 2 squared would be 4. So that's the number that's going to go over here. And of course we have to add those fractions on the right hand side as well. So it's going to look something like this. Okay, something like that. Okay, so now what we have to do is we're going to follow step 3 here. We're going to factor this one and add up these terms. Okay, so in order to add up the terms on the right hand side, actually what I'm going to do is I'm going to change them to a decimal, because the negative 17.5 is a decimal, right? So I could just do that and then just add up these numbers. Now I'm kind of running out of space here a little bit, so let me just continue up top here. Okay, so we have this example. Moving on here, as you know, if you add up all these numbers, so see for yourself, if you just add up all these numbers, you actually just end up getting 1. Okay, so that's just going to be 1. And the way to factor this, remember that shortcut that I told you, is that you have to take the middle term, in this case negative 7, and then just divide it by 2. So that'd be negative 7 over 2, negative 7 over 2. Here the middle term is negative 5, so just divide that by 2. Negative 5 over 2, negative 5 over 2. Okay. And also notice that when you multiply, negative 7/2 times negative 7/2, you get 49/4. So we factored it correctly, and we can write it like this. Okay, because here there's 2 of these terms, so we can write it squared, and here there's 2 of these terms, so we can write that squared. Okay. All right, everyone. So now that it's in standard form, we can just identify the center and the radius. So in this case here, the center is going to be at 7/2 and 5/2. Those are the coordinates of the center. Okay. And we have to graph it, so we should probably write it as a decimal, so 3.5 and 2.5. And the radius is going to be the square root of this number, which is the square root of 1, which is just 1. So the radius here in this case is going to be 1. So now that we have the center, negative 3.5 and 2.5 is the center, and the radius is 1, so we just put a radius of 1 around the center here, and we have our circle. Okay, so this is the graph of the original equation that we've graphed in general form.